Welcome back to Developer's Introduction to Data Science. Probably many of you are already familiar with the traditional programming logic, so let's try to understand machine learning leveraging traditional programming logic. This is an image that shows you the difference in how traditional programming is created versus a machine learning model. Traditional program is a statically programmed logic to get a specific output. Static results are generated based on the program logic in the algorithm. In machine learning, and specifically in supervised machine learning, you have your data, which are your features, and then you have an output, which are your labels. That goes through the algorithm computation, and a model is created which at the basic level is a function, is a mathematical function created with the data. This is called training your machine learning model. In machine learning, there are two different categories. One is called supervised learning, and the other one is unsupervised learning. Supervised means that we are giving examples of both the data used to predict and the answer. For example, is a dog or is a cat? We would be giving the model tag image of each category for dog and for cats, and we would tell him what a cat and a dog is. Then the model would learn from the tag data provided. Unsupervised learning is when we give an untagged data set to learn from without giving it the answer of what we want it to learn. As you can see, under the supervised machine learning, there are two methods, regression and classification. While under the unsupervised machine learning, there are three different methods, clustering, anomaly detection, and recommendation. Now that we have a bit of understanding of what machine learning is, let's look at the model building process at high level. As you can see, there are four main stages. There is prepare your data, train your model, test your model, and operationalize your model. Prepare your data. In this stage, you need to find, select, and create the data, applying pre-processing techniques and also fill gaps in your data. Train a model means that you have to give your model specific data so that your model is going to learn from this data to predict something in the future. This is a very iterative task because you may need to change the data in the model until you think that you have a good candidate for the production stage. Test the model. Now that you have a model and that you think is going to perform very well, you can test it with new data. Finally, operationalize your model. Now it's the time to operationalize your model so that you can consume it from different applications.